Hello, lovely humans. Welcome back. We're going to do trig antiderivatives now. And it is really just the undoing of a derivative. So we kind of have to remember how to take the derivative of regular trig functions. Okay. So let me remind you, I always use this little rule. Remember, sine, cosine, negative cosine. Going clockwise is taking the derivative. So the derivative of negative sine is negative cosine. Derivative of negative cosine is sine, so on and so forth. Going counterclockwise, antiderivative would give us our integrals or our antiderivatives. So the antiderivative of sine is negative cosine. The antiderivative of negative cosine is negative sine, so on and so forth. Okay. So if I remember, the derivative of sine is cosine. So the antiderivative of cosine would be the sine x plus c. So just undoing the derivative. So the derivative of cosine is negative sine. So the antiderivative of sine would be negative cosine x plus c. So I can see sine, the antiderivative is negative cosine. All right, so tangent, tangent is, the derivative of tangent is secant squared. So the antiderivative of secant squared would be tangent x plus c. The derivative of cotangent x, well, there's an extra x right there, is equal to negative cosecant squared x. And so the antiderivative of positive cosecant squared x would be negative cotangent x plus c. The derivative of secant is equal to secant tangent. So the antiderivative of secant tangent would be secant x plus c. And the derivative of cosecant is negative cosecant x cotangent x. So the antiderivative would be cosecant x negative plus c. I have one more trick to helping me remember the derivative and antiderivative of tangent and secant. Okay. I remember that, I just remember this. Psst. And then you cross off the P and you go like this. The derivative of secant is secant tangent. Okay. The antiderivative of secant tangent is secant. Okay. If we look back up here, the derivative of tangent is secant squared. The antiderivative of secant squared is tangent. And that's how I remember those. Okay. Just to help me. All right, so we're going to do some antiderivatives using trig, everyone's favorite. So the integral of sine over cosine squared x, I am going to use a trig identity. Let's rewrite this in a way that makes more sense. So sine x over cosine x times cosine x, and I'll put a 1 on the top, dx. And I'll just put parentheses around it, just so I know that everything in there is getting the integral applied. Okay, so this sine over cosine of x is tangent x times 1 over cosine is secant x dx. So now that looks a little bit nicer, I can look back and I'm like, okay, remember, psst. So the derivative of the antiderivative of secant tangent is secant x plus our constant of integration plus c. Okay. Next, cotangent times sine. Let's see if we can simplify that a little bit. Cotangent is cosine x over sine x times sine x dx. Sines cancel, leaving me with the integral of cosine x dx. The the antiderivative of cosine is sine x plus c. Okay. Number 3. So this one looks really bad, but it's actually okay. We're adding trig ratios together. So this, since I have terms, I can just take the antiderivative of each part of my function that I'm adding. So the antiderivative of secant squared is tangent x. The antiderivative of positive sine, so again, positive sine, that I'm going to go counterclockwise, so I'm going to negative cosine of x. The antiderivative of cosecant squared is positive cotangent x. Oh, sorry. The antiderivative of cosecant squared x is negative cotangent, so it's going to be the opposite sign, so cotangent x. And then I'm adding my constant of integration. These really you just kind of have to remember. Number 4, and our last one for this video, is the integral of negative times the quantity secant x tangent x minus cosine x dx. I will distribute, so I get negative secant x tangent x plus cosine x dx, and I'm going to put that in parentheses. And I remember that there's like some relationship with secant tan. Remember? The antiderivative of secant tan is secant, but it's negative. So I get negative secant x. And the derivative of cosine taking the antiderivatives, that would put me at sine, is sine x plus my constant of integration. That's that.